All right, let's jump straight into today's explainer and unpack the sheer engineering magic that makes modern search as you type experiences feel, well, instantaneous. We interact with these search bars literally every single day, whether we're hunting for shoes, digging through some dense software documentation, or asking an AI a complex question. We just expect it to work. But what is actually happening in those crucial milliseconds between you typing a letter and the perfect result popping up? Today, we are tearing down the engine to see exactly how it works. Here is our roadmap. First, we'll look at the modern search revolution. Second, we're going deep inside the Meilisearch engine. Third, we'll explore how it processes and compresses text. Fourth, we'll break down deterministic ranking rules. Fifth, we'll look at adding AI with hybrid search. And finally, we'll wrap up with a fascinating comparison: Meilisearch versus Algolia. So, starting with part 1, the modern search revolution, and why we are finally replacing those bulky, legacy analytical clusters. To really appreciate modern search, we've got to understand why older, traditional search architectures simply fall flat in today's rapid-fire user interfaces. You know that feeling when you type a perfectly spelled query on an older website and it gives you completely irrelevant results? Or you make one tiny, minor typo and suddenly 0 results? It's incredibly frustrating, right? Well, that bad user experience actually stems from a very specific architectural choice made decades ago. The culprit is usually old-school statistical scoring, like BM25. Now, don't get me wrong, BM25 is a fantastic algorithm if you're, say, ranking long-form research papers or sorting through massive server logs. It uses this heavy math formula based on term frequency. But for a modern front end, it completely fails, because it mathematically favors rarer words. An obscure word buried in a product description might accidentally outscore a perfect, exact match in the actual product title. Plus, it treats typos as entirely distinct tokens. If you accidentally misspell coffee, the whole system just breaks. Modern deterministic pipelines, on the other hand, are engineered for sub-50 millisecond latency, hyper-predictable ranking, and absolutely strict typo tolerance. Moving to part 2, inside the Meilisearch engine itself, specifically its Rust architecture and memory management. What's really fascinating here is how Meilisearch actually solves these legacy problems. They built a memory-safe Rust architecture from the ground up. At its foundation is a storage layer utilizing something called LMDB, which stands for Lightning Memory Mapped Database. Instead of manually managing heap memory caches like older databases have to do, Meilisearch just delegates the storage entirely to LMDB. It essentially maps the index file on the disk directly into the operating system's virtual memory address space. In plain English, it completely bypasses the middleman. Read operations hit the OS's page cache directly at raw memory speeds using zero-copy operations. It is literally blisteringly fast. But wait, before any actual search can happen, that raw text needs to be cleaned up. The data flows through a specialized internal engine called Charabia. Charabia beautifully cleans and segments everything. It strips out diacritics, so a word like cafe with the accent simply becomes cafe. It lowercases everything, normalizes crazy script variations in languages like Persian or Arabic, and seamlessly handles complex Chinese, Japanese, and Korean characters that don't even use spaces. This heavy lifting guarantees that no matter how chaotic the user's input is, the underlying text is uniformly prepared for a perfect match. All right, section 3. Let's talk processing and compression and uncover the efficiency behind FSTs and roaring bitmaps. A massive challenge in search is figuring out how to store every single word in your database without completely maxing out your RAM. Meilisearch tackles this using a data structure called a finite state transducer, or an FST. Think of it like treating words as a giant interconnected graph. Words like car and cat actually share the exact same CA prefix branch. Because of this, Meilisearch can gracefully navigate typos. Instead of scanning a massive, flat database list, it intelligently walks this graph state by state, hunting down valid matches in a fraction of the time. And the efficiency gains here are just wild. By simply sharing those character prefixes and suffixes, rather than storing every single word individually, it slashes dictionary RAM usage by an astonishing 80 to 90%. That is a game changer, allowing you to process enormous data sets with minimal overhead. Right alongside the FST, we have roaring bitmaps. Imagine you're on a shopping site. You click a filter to only show shoes under $50 that are blue. You are asking the system to intersect multiple massive categories instantly. To do this, roaring bitmaps dynamically compress document IDs into tiny 16-bit chunks.
This lets the system execute set intersections across millions of document IDs in mere microseconds. It is quite literally the secret sauce behind those instant facet filters we all love on modern web stores. Section 4, deterministic ranking rules, and a really cool concept called the bucket sort pipeline.
Okay, so we've found the matching documents, right? But how does the engine actually decide which one gets that highly coveted #1 spot on your screen? Think of this bucket sort pipeline as a series of physical tiebreaker sieves, no messy, unpredictable math scores here. Documents flow through strict logical rules. First, words. Documents matching all query terms win. Then, typo. A 0 typo match will unequivocally outrank a match with 1 typo. Then, proximity. If the words are closer together, they rank higher. It marches straight through attributes and exactness in the exact same strict manner. The result is hyper-predictable. Developers and users get exactly what they expect every single time. Moving to Section 5, let's see what happens when we add AI to the mix with hybrid search. Now, keyword search is fantastic for precision, for sure. But the new frontier is semantic, AI-driven queries. To handle this, Meilisearch didn't just bolt on a third-party tool. They built the Arroy engine in-house. It's a vector storage engine built directly on top of their existing LMDB storage. It automatically handles text chunking and vector generation, talking seamlessly to AI models like OpenAI or Hugging Face. The true beauty of this architecture is that it stores complex AI embeddings right alongside your standard text data, keeping the whole operation incredibly streamlined. The real magic happens when these two worlds collide. Through hybrid score fusion, a single user's query essentially branches out. It executes the traditional keyword search and the AI vector search in parallel at the exact same time. Then it smoothly blends those results together based on a ratio you configure. You literally get the best of both worlds, the strict exactness of traditional search powered up by the deep contextual understanding of modern AI.
Finally, Section 6, the showdown, Meilisearch versus Algolia, and their contrasting architectural trade-offs.
So now that we understand the internal mechanics, we can look at a really fascinating architectural comparison between open-source Meilisearch and the proprietary SaaS giant Algolia. The trade-offs are pretty stark when you lay them out. Meilisearch is open source, built in Rust, and uses memory mapping. Algolia is a proprietary SaaS built in C++ and uses high RAM in-memory storage. While they both achieve those instant sub-50 millisecond results, their approaches are totally opposed. Algolia relies on keeping massive amounts of data heavily loaded in RAM across global servers. Meilisearch, on the other hand, uses that virtual memory mapping we talked about to efficiently handle datasets that are actually way larger than the available hardware RAM. To boil it down, both systems, thankfully, reject the unpredictability of old-school BM25 scoring. They both want those strict tiebreaker rules. So your choice ultimately comes down to infrastructure philosophy. Are you looking for total data sovereignty, highly predictable infrastructure costs, and the ultimate flexibility of an open-source tool like Meilisearch? Or do you prefer paying for a fully managed enterprise platform with all the built-in visual merchandising tools, even if it requires a massive, expensive RAM footprint like Algolia? The underlying takeaway from all of this is crystal clear. Trying to force traditional, heavy analytical database engines to handle instant modern user interfaces, yeah, those days are over. The engineering simply has to be streamlined and deterministic if you want to meet today's demanding user expectations. Which leaves us with a truly compelling question about the future of our tech stacks. As open-source tools like Meilisearch perfectly balance cost, native vector AI, and blazing fast speeds through highly optimized memory mapping, will the massive RAM footprints and the sky-high costs of purely in-memory proprietary giants even remain justifiable in the years to come? It's a massive shift in software architecture, and it's absolutely one worth keeping a close eye on.